Once every 30 years, a planet-wide megastorm engulfs Saturn. It's called the Great White Spot, and we don't know exactly why it happens. It takes about 2 years for the storm to fully form and another 2 years to dissipate. That means that when you see the storm, half of it is already gone. In other words, the further along the storm is in its life cycle, the less white it is. The storm starts off white because that's how high-altitude clouds look against the dark backdrop of space. But as the storm ages, it turns orange and then red, because the clouds start reflecting the light of the sun more like Earth's desert sands. The storms are so big they leave scars in Saturn's atmosphere that stay for decades, and scientists can use those scars to track what happened in the years before they were discovered. The first record of the Great White Spot was made by Giovanni Cassini. Back in 1672, he saw a huge bright cloud in Saturn's northern hemisphere, covering a massive area and lasting for years. Since then, we've only seen 3 full cycles of the Great White Spot, 1 partial cycle, and 3 partial storms. That means there's still a lot that we don't know about these storms. What we do know is that once every 29 or 30 years, the storms seem to start up again. The last one started in 2020 and ended just this year. But right now, scientists are beginning to spot signs of another storm forming. They could be seeing the early stages of it here in 2023, which would mean that the next great storm is happening earlier than expected. To understand why these storms happen on such a strange schedule, we need to talk about Saturn's atmosphere. Saturn's atmosphere is mostly hydrogen and helium with some methane. Methane is great at absorbing red light and reflecting infrared light. That's why Saturn looks yellow from Earth. As for the storms themselves, they start deep in Saturn's atmosphere. Massive storms brew when hot gases from deep inside the planet rise up through the atmosphere and cool, causing water vapor to condense into clouds. When that happens, some of the light that hits those clouds gets reflected back into space. And if we're looking at the right wavelengths of light, we can actually see the clouds. That's the white spot that Cassini saw all those years ago. We think that what fuels these storms is something called convection. Convection is what happens when warm air rises and cooler air sinks, kind of like boiling water on the stove. As the warm gases rise through the atmosphere, they expand and cool, forming clouds. Then as they reach their maximum height and begin to cool even more, they start to rain. But instead of water, they rain supercooled alcohol and methane. And just like rain on Earth, this can form clouds all on its own. So as the clouds get heavier and heavier, eventually they fall back down to the surface, and that's what creates the second white spot. What we don't really understand is what causes these powerful rising currents in the first place. Storms on Earth are fueled by temperature differences between the equator and the poles. Hot air from the equator rises, and cold air from the poles sinks. But Saturn's equator and its poles are not that different in temperature. So it's not clear what drives the convection on Saturn. One idea is that it's all about the tilt. Saturn is on its side, compared to Earth, which is pretty much upright. Every year, Saturn experiences extreme seasonal changes. Each pole goes from 6 months of daylight to 6 months of darkness twice a year. And it's possible that these dramatic shifts in energy drive convection in Saturn's atmosphere. But if that's the case, you'd expect storms to occur every year, not once every 30, so clearly there's more going on. Scientists think that the tilt might be the thing that kicks off the convection currents. But it's not enough on its own to keep them going. Maybe the atmosphere needs a little nudge to get the convection really strong. Scientists have a few ideas for what that nudge might be. One has to do with the rotation of Saturn. The planet rotates pretty quickly, and that creates powerful jet streams in its atmosphere. Every year, those jet streams shift with the changing seasons. And maybe the atmospheric bulge, caused by those shifting winds, is what creates the conditions for the storms to form. But that doesn't explain why the storms only happen every 30 years. For that we need to consider the moon Titan. Titan orbits Saturn every 40 days. And it makes for a pretty good case study. We know that Titan's orbit is elliptical. so sometimes it gets closer to Saturn and sometimes it gets farther away. So as Titan swings closer and farther away from Saturn, it tugs on the planet's atmosphere, and that tugging could be what triggers those powerful convection currents. Unfortunately, no spacecraft has ever measured the winds around Saturn at the same time Titan passes by, so we don't know for sure if that's what's happening. Plus, we can't observe the entire Saturn system from Earth. The moons are too close to the planet, so we don't know if anything else is triggering the storms. There could be some sort of interaction between Saturn and the rings, or maybe it's some kind of magnetic effect or radiation, or maybe it's a combination of factors. Now, it's not just the great white spot that's hard to predict. All the features on Saturn's surface move in strange ways during these storms. Jet stream winds can reach 900 miles per hour. They spread out from the storm and weaken as they move away from the center. Those wind patterns leave behind scars in Saturn's atmosphere that stick around for years, if not decades. And those scars help us figure out what happened before we actually get there. Since we know that the jet streams spread outward from the storm, we can measure the speed of the winds by measuring how fast those streaks move. That tells us what the wind speeds were at that distance from the storm. And by combining that data with our knowledge of fluid dynamics, we can model what the wind speeds were throughout the storm. That means we can reconstruct what a long-gone storm looked like, and figure out how strong the winds were, how big the storm was, and how tall the clouds got. In 2010, scientists studied the 2004 storm, which was the last one that completely formed within the solar system. And they estimated that the storm was 10,000 miles wide and reached over 300 miles up through Saturn's atmosphere. Here you can see the scars left by that storm, still visible 8 years later, in 2018. This technique is helping scientists learn about storms that happened way before humans were looking up at Saturn with spacecraft. For example, researchers identified a jet stream scar from an unknown storm in Saturn's southern hemisphere in 1980. Back then, NASA's Voyager spacecraft was exploring the outer solar system, and it spotted a storm in Saturn's northern hemisphere. But since it had already passed the planet, it didn't see any scars in the south. It's likely that this unidentified storm was similar to the ones we have observed, though the jet stream winds may have been strong enough to blow over 400 miles high through Saturn's atmosphere. In fact, studying these ancient scars suggests that the storms might be getting stronger and more frequent. Scientists have found several scars that date back over 300 years, and most of them were created during periods when the storms were supposedly inactive. According to our observations, the frequency of the storms should be decreasing, but it seems like they've been increasing in strength. And this brings us back to the storm that ended just this year. Scientists began spotting signs of it back in 2020, when they saw a series of unusually bright spots in Saturn's atmosphere. But this storm never quite grew into a true great white spot. It peaked in 2022, but it was very faint and small compared to previous storms. And now it's basically gone. If it was the next storm in line, that would mean that these cycles aren't really 30 years long. They're 60 years long. But if that's the case, we should be seeing signs of another storm soon, and scientists are already starting to spot hints of one. If it is the next storm, it could tell us a lot about what happened in 2022. After all, we know that storms tend to repeat themselves. So by understanding what happened during the Great White Spot of 2022, we'll be able to better understand the storm that's forming right now. And when we finally see it, it will reveal the secrets of what really happens on Saturn every 30 years. Thanks for watching this episode. If you want to help us explain even more mind-blowing space stuff to the whole internet, we have a Patreon, where the people who want to support the work that we do that, so that we can keep doing it. You can find it at our support page.